What's up, ladies and gentlemen, boys and girls? This is Mr. Richardson coming at you live through the power of the internet. What we're going to be talking about today is factoring again, but specifically factoring using the difference of two perfect squares. Before we get into how to factor the difference of two perfect squares, what we should talk about is what you're going to get when you do this type of factoring. What you'll always get is what's called conjugates. Conjugates are a special type of binomials. What they are, they're binomials that only differ in the sign of the second term. For instance, x minus 3 and x plus 3. Notice that only differed in the sign of the second term, negative 3 and positive 3, while the first sign of x stayed the same. Here's another example, 2x plus 17 and 2x minus 17, 4x plus 5, 4x minus 5, 25 plus 976, 25 minus 976, any binomial that only differs in the sign of the second term. Why conjugates are so important is what happens when you multiply them. Well, remember what happens when you multiply two binomials. You have to double distribute, commonly referred to as foiling. Well, something special happens when you multiply conjugates. When you multiply conjugates, you will double distribute or foil, but because of the signs of the second terms being different, the O's and I's will cancel out, and you'll actually only have, instead of 4 terms, you'll only be left with 3 terms because the O's and I's cancel out. When you factor using the difference of two perfect squares, your factors will always be conjugates. So let's look at how to do this. If you want to factor by the difference of two perfect squares, the first thing is you need to have the binomial in this standard form. Now it's the difference of two perfect squares, so notice there's only two terms. There's this ax squared term, and then there's a constant term separated by a minus sign. It can't be a plus sign, it has to be a minus sign. When you want to factor with the difference of two perfect squares, what you should do is just take the square root of the ax squared term, that first part, and then take the square root of the c term. After you've taken those square roots, what you're going to do is use those solutions from part 2 to create a conjugate pair. I'll show you what I mean in a few examples. In this first example, I want to factor it using the difference of two perfect squares. Notice that it's in the form I want, ax squared minus c. So the difference of two squares will always factor like this, and I just need to take the square root of 4x squared. The square root of 4 is 2. The square root of x squared is x. So in the fronts here, I'm going to have 2x. Next, I take the square root of the c term, that's 64. The square root of 64 is 8, and I'm finished. If I want to check my answer, I could double distribute or FOIL, and what I'll see if I do so is I'm left with the standard form here of this conjugate pair. Let's factor the second one here. Again, the difference of two squares always factors like this. Notice that the two signs I used were different. Here plus and minus, here minus and plus. The order does not matter. I'll take the square root of the first part. The square root of x squared is x, and the square root of 144 is 12. This here is now in factored form. Let's go to factor the third expression. When I go to factor this third expression, you have to look at it closely. Well, if you look at it, what you should see is that it's separated by a plus sign. Because it's separated by a plus sign, this cannot be factored using the difference of two perfect squares. There must be a minus sign in between your two pairs in order to use that. But this does factor. It's a different type of factor we learned earlier. This would just be GCF factoring. The GCF of 16x squared and 100 is just 4. I do not have a variable GCF because 100 doesn't have a variable. So here I can factor out of 4. 16x squared divided by 4 is 4x squared, and 100 divided by 4 is 25. This does not factor any further. This is as far as this one will go. Let's have you try an example of factoring with the difference of two perfect squares. Factor this following binomial. Okay, if this is the difference of two perfect squares, it will always factor to this form here with a plus and a minus. I take the square root of the first part, the square root of x squared is x, then I take the square root of 100, the square root of 100 is 10. If you want to check your answer here, you can double distribute or you can FOIL and see that this is the correct factored form. Let's try another one. See if you can factor this binomial. Okay, this one is in the correct form to use the difference of two squares. So I'll have one plus sign and one minus sign. Take the square root of the ax squared term. The square root of x squared is just x. Take the square root of the c term. The square root of 1 is just 1. Let's try another example. See if you can factor this binomial. To factor this one, it is in the correct form for a difference of two perfect squares. It does look like the terms are in opposite places, but they are both perfect squares, so I can use this plus and minus notation. The square root of 25 is 5. The square root of 16x squared is 4x. The terms need to be in this order in order for it to work. You could have not put the 5's in the back and put the 4x's in the front. If you were to try this formation here, you could see it does not work. Check that. Foil these and see that this answer here will not work. Let's try one more. See if you can factor this binomial. Were you able to do it? Well, this one here actually is not the difference of two squares. I know it looks tricky, and maybe it is or maybe it isn't, but in fact it's not. This term here is not a constant term, and it's not a perfect square. And 8 also is not a perfect square, so that may have you thinking, how do I identify when to use this type of factoring? Well, the best way to identify when you can use the difference of two perfect squares is to look at the form. You need to have a binomial, meaning two terms, and you need to be missing a bx term. Anytime you have a bx term, like here I have 4x, I cannot use the difference of two squares. Look at the previous examples where I was using it. Notice how there's no term with a variable x. The next way to identify the difference of two perfect squares is to look at the difference. It's right in the name. They need to be separated by a subtraction sign. As soon as you have a plus sign separating the binomials, they will not factor using the difference of two perfect squares. And the last thing that you need to do to use the difference of two perfect squares is all of the numbers you have, all of the constants, need to be perfect squares. Looking at this one here, 8 is not a perfect square, so it would mean it would not factor by the difference of two perfect squares, and 4x, you may not have a bx term to do this. Well, it does factor, and this factors by GCF. The GCF of 8 and 4 is 4, and of x squared and x, it should be x, the one with the lower exponent. 8x squared divided by 4x is 2x. 4x divided by 4x is 1. I hope this video helped you find out how to factor, specifically by using the difference of two perfect squares. Hope to see you here next time. Thanks.